Let us solve the system of equation x square plus yz equal to 1, y square minus xz equal to 2, and z square plus xy equal to 1. So we have three different equations that needs to be solved simultaneously. Now we observe that if we subtract equation 3 from 1, we get x square minus z square, and we can take y common and something like we get x minus z as well. And right hand side is just 1, 1, and let's do it. Subtracting equation 3, we write equation 1 x square plus yz equal to 1, and then we subtract equation 3 from this equation. Equation 3 is z square plus xy equal to 1, so minus 1. So we are subtracting equation 3 from equation 1 to get right hand side equal to 0. What about left hand side? X square minus z square plus yz minus xy. You see, you can factorize x square minus z square and write it as x minus z whole thing into x plus z. What about this one? Take minus y common and you are still left out with x minus z equal to 0 as it is. See, x minus z you can take common. If you take x minus z common, you are left out with x plus z minus y equal to 0 as it is. Now you have product of two number equal to 0. One number and second number, their product is 0. So one of them has to be 0. You don't know which one. So let's assume x minus z equal to 0. Or maybe x plus z minus y equal to 0. We don't know which one is 0. So let's do case 1. X minus z equal to 0. That is same as saying z equal to x. Let's write z equal to x in equation 2. If I write z equal to x in equation 2, I get y square minus x square equal to 0. By equation 2, y square minus xz equal to 0. Y square minus xz equal to 0. Now we write z equal to x to get, therefore, y square minus x square equal to 0. That will give us y square equal to x square. So y equal to plus minus x. Okay, so we have z equal to x and y equal to plus minus x. So let's write that in equation 1. From equation 1, x square plus yz equal to 1. If I take z equal to x, therefore x square, we know that z equal to x, so x square plus xy equal to 1, but y equal to plus minus x. If y equal to x, then y equal to x, so 2x square equal to 1, so x equal to plus minus 1 by root 2. Now is y equal to x and z is equal to x, that's the case we have started with. Therefore x comma y comma z equal to, all the three being equal, 1 by root 2 comma 1 by root 2 comma 1 by root 2, or minus 1 by root 2 comma minus 1 by root 2 comma minus 1 by root 2. Okay, that's the case corresponding to, that happens if y equal to x. What if y is equal to minus x? If y equal to minus x, then by this equation x square minus x square equal to 1, which is not possible. So we are done with case 1. In case 1 we got xyz equal to 1 by root 2, 1 by root 2, 1 by root 2 and minus 1 by root 2, minus 1 by root 2, minus 1 by root 2. What about other case? Let's do it. Let's do case 2. Case 2. X plus z minus y equal to 0. X plus z minus y equal to 0. That means z equal to y minus x. Let's look at the equation 1 and 2. Let's write the value of z in equation 1 and 2. By equation 1, x square plus y times y minus x equal to 1, that is x square plus y square minus xy equal to 1. By equation 2, y square minus xz equal to 0, but z equal to y minus x, so y square minus x into y minus x equal to 0. That gives us y square minus xy plus x square equal to 0. See, here you have x square plus y square minus xy equal to 1, and here x square plus y square minus xy equal to 0. Same number equal to 1, same number equal to 0. That's not possible, which is not possible. So what happens is that in case 2 we could not find any real number that satisfy all the 3 equations. So in case of case 2, no solution. So therefore final solution is, therefore only pair of solution is x comma y comma z equal to 1 by root 2 comma 1 by root 2 comma 1 by root 2 and minus 1 by root 2 minus 1 by root 2 minus 1 by root 2. That's the only possibility.